We have seen one. We have seen one chemical properties of amines. Let us look at one more, and then we will look at the basic character of amines. Right, the second reaction, that is alkylation. This reaction, that is alkylation of amines. We have also seen this reaction in the method of preparation. What is the reaction? The reaction is when you have R NH2 and you react this with any alkyl halide R dash X. This is going to give you a salt, which is going to be R, nitrogen, which will be attached with two hydrogens as previously, and it will be also attached with the alkyl group R dash. And there will be a positive charge in the nitrogen atom, and this positive charge will be stabilized by the allied ion, that is X negative. When this salt is treated with any base, it gives you secondary amine, that is R bonded with NH, further bonded with R dash, plus the halide ion leaves. Now, when this reacts with one more, if it gets any alkyl halide, then this would again react with the alkyl halide, giving you a tertiary amine, that is R nitrogen, R dash, and R dash. Okay. Obviously, this is the first step, and the second step you have to add any base, OH negative. But even if in the exam they give you just like this, you just draw the whole thing, है ना? कि आपने OH negative डाला, उसके बाद आपको ये मिला, fine. So you start with 1 degree amine, then this is 2 degree amine, and then this is 3 degree amine. So basically, what we can do, we can use 1 degree amine and 2 degree amine to make 3 degree amines using alkylation. So what happens here? 1 degree and 2 degree amines reacts with alkyl halide to give 3 degree amine. Now let us suppose we have a very simple compound, that is CH3NH2. Now in the first step, I am adding ethyl chloride, CH3CH2Cl, and the second step I am adding NaOH. So from 1 degree, I will get 2 degree amine, that is CH3 bonded with nitrogen, and then you will have hydrogen, and this nitrogen will have the ethyl group attached, 1 carbon and 2 carbon. So ethyl group is attached. When I react this once again with ethyl chloride, the second step I will add OH negative, then I will get a tertiary amine, that is CH3, which is bonded with nitrogen, and there are 2 ethyl groups. Now the reaction is the reaction is not very complex. It is simple reaction. But an important thing that I want to teach you guys here, it is regarding the nomenclature of these type of compounds. Okay. So let us look at the last compound, that is 3 degree compound. So this is 3 degree, and if I start the nomenclature, I will start with the functional group. The functional group here, it is nitrogen is attached with carbon atom. That is why it is going to be amine. If I talk about unsaturation, then AN, because we don't have any double bond or triple bond. And when you are going to talk about the parent, then parent is going to be either, just give me a second, either these 2 carbon or these 2 carbon, because though 2 carbons are the maximum number which are in chain, right? If you are saying, sir, can we do something like this? We start with 1, 2 carbon atom, then nitrogen, and then CH3. No, because it is not a carbon chain. In between, we are having a nitrogen atom. So this cannot be a carbon chain. That is why the longest carbon chain that you can have, which is attached with the functional group, is these 2 carbon atoms, right? So this carbon atom is attached with nitrogen, or you can take this one also. There is no issue. But koi ek hoga, and both of them are what? Having 2 carbons, meaning the parent is going to be eth. Now, if I talk about the substituent, what is the substituent? See, this nitrogen has already been covered in the functional group. ये functional group में cover हो चुका है, and parent has also been covered, right? So what remains after the identification of puff? There is a ethyl group and there is a methyl group. Okay, so we have ethyl group and we have a methyl group. When you are going to number the carbon chain, you'll start with this one carbon and this is to second carbon because this is nearest to the functional group. But when you look at the substituent are not directly attached with the parent carbon. So how do we number the substituent? Now, in this case, when nitrogen is attached with methyl and ethyl, when the substituent is attached with nitrogen, then we write it like this: N-ethyl, meaning N, it shows that where it is attached. It is not the normal ethyl, it is N, means where it is attached, and N-ethyl. So N-ethyl and N-methyl, it shows that the ethyl group and the methyl group are attached in the nitrogen of the amine functional group. Does this make sense? Yes or no? Please tell me, guys.
Yes,
हाँ
sir.
जी बताएं. ठीक है, तो the name for this compound is going to be, we'll start with N-ethyl because E is alphabetically before M. N-ethyl, N-methyl, ethane, amine. ठीक है. Similarly, try to write this whole thing down and then write the name of this compound. ठीक है, write the name of this compound. Raise your hand once you're done. Please write it down. Raise your hand once you're done writing. Waiting for Aliza, Deborah, and Sophia. Okay. लेकिन नाम नहीं आया किसी का अभी तक. Nobody has sent me the names. Name of this compound. So in this case, the parent carbon will be these two carbon atoms. We have amine and we have one substituent. That means it is going to be N methyl ethane amine. ठीक है, write this down. Lower your hand once. Please, you can lower your hand now. ठीक है. Right, next, basic character. So the third property, ठीक है, बेसिक कैरेक्टर. नाउ व्हाई डज इट शो बेसिक कैरेक्टर? Because amines, they have a lone pair electron on the nitrogen atom. When it reacts with water, it's going to give you R that has bond with nitrogen with a positive charge and three hydrogens. So basically, this lone pair electron, it attacks on the H plus of water, and you get OH negative. So because it is abstracting the hydrogen atom, the concentration of OH negative is going to increase, and that is why we say amine is what? It is basic in nature. So RNH2 amines abstract H plus ion. Therefore, due to the presence of lone pair electron on nitrogen atom, therefore amines are Lewis base. Therefore, amines are Lewis base. Okay. Now, if you're going to write the dissociation constant for this reaction actually shows the basic nature of amines. So if you're going to write the dissociation constant, that is Kb, Kb will be equal to the product OH negative divided by H2O. Okay. Now, since H2O, it is what? It is also, see, H2O is also complete liquid, and the concentration of liquid solids are taken as one, right? Or they are constant. That is why we ignore this, and rather, इसको आप ऐसे समझिए, इसको Kb मत लिखिए अभी. You write it as K. And when you write Kb में आपके पास this water molecule is not written. So you have RNH3 positive, OH negative divided by R NH2, and water is not there. Okay? But this is what? Kb. Now, if a base is strong, if a base is strong, it will give you high amount of OH negative. That means the concentration of products will be higher. When the concentration of product is higher, the numerator part is higher. When the numerator is higher, the value of Kb will be higher. That means strong base have higher Kb. The dissociation constant will be higher. ठीक है, ये चीज बिल्कुल ध्यान रखिएगा. स्ट्रॉन्ग बेस का क्या होगा? दे विल हैव हायर Kb. There is a term that is known as pKb. pKb, which is equal to minus log of Kb. Now, strong base का Kb ज्यादा होता है. So please see, if Kb is higher, then what will happen? The log Kb will be higher. But if you include a negative sign on log Kb, then the value will decrease. And this minus log Kb is nothing but it is pKb. So pKb will also be lower. और Kb high किसका होता है? Strong base का. So for the case of pKb, what I can write? Strong base have lower pKb. ध्यान रखिएगा इसको. Strong base have lower pKb. Write this down. Raise your hand once you're done. जैसे पीएच होता है ना, या पीएच इज व्हाट, माइनस लॉग ऑफ एच पॉजिटिव। ठीक है, तो जैसे लॉग होता है, सो लॉग इज व्हाट, इट इज अ फंक्शन। साइन एक फंक्शन होता है, कॉस एक फंक्शन होता है, राइट। सो उसी तरह से पी फंक्शन होता है। पी का मतलब होता है माइनस लॉग। पी का मतलब होता है माइनस लॉग। Also, PK and PKB are concepts from 11th standard equilibrium. I hope it is not the first time you're hearing about PKB. pH, POH, PKB, PK, all of these are concepts from 11th standard equilibrium. Write this down, raise your hand once you're done. Waiting for Aliza, Safia, and Fadil. Waiting for Aliza and Fadil. Waiting for Fadil. See you now. So one thing that we have already seen is amines are basic because of the lone pair electron. Okay. So now we are going to compare the different types of amine, starting with ammonia, a nitrogen atom which does not have any alkyl group. It only have hydrogens. Next, primary amine which has one alkyl group. Then we will have secondary amine which has two alkyl groups. And then you have the tertiary amine which has three alkyl groups on it. Here we are having three alkyl groups. Okay. Now there is lone pair here. There is lone pair in the nitrogen atom. There is lone pair in the nitrogen atom. There is lone pair in the nitrogen atom. Now, the alkyl groups, since it is a plus I group, which is going to give electron density towards the nitrogen atom. So one alkyl group is going to increase the electron density. Two nitrogen atoms will increase the electron density doubly. Or if you are having three alkyl groups on the nitrogen atom, then three alkyl groups are going to give electron density on the nitrogen atom, and they will increase the electron density. And if they are increasing the electron density on the nitrogen atom will easily give the electrons and act as a Lewis base. So if I am only looking at the electronics, I'm only looking at the electronic effect, that is the plus I effect of the alkyl group, then in that case, I will say that the 3-degree amines will be most basic because it has three alkyl group which are giving electron density and they're increasing the electron density on nitrogen atom, followed by 2-degree and followed by 1-degree. And then at last we'll have the ammonia. This is the order for basicity. But I have to look one more thing. What other thing that I have to look is this ammonia is going to attack to an acid. Here, this primary amine is going to attack on the acid, the secondary amine, and the tertiary amine. Now look at the sizes. Now please remember, when I am writing alkyl group, the smallest alkyl group that can be present is CH3. अगर हम smallest की बात करें, then it is going to be carbon with 3 hydrogens like this. Now this will give you a proper picture of the size when I write alkyl group. Now you tell me which will be the easiest. कहाँ, like according to the moving, yeah, like the motion of amine, which of these four can easily move? Tell me that. Ammonia, 1 degree, 2 degree, or 3 degree. Which of the following can easily move? क्या ख्याल है आप लोग का? Tell me, what do you think? Don't, no pressure for right answer. Just look at the size and tell me which will be the easiest to move, which will be most mobile, which of the following can move easily. One, the ammonia, according to the size, you guys tell me. Please have a logic also while you are answering. If we have large size, then it will move easily, or if we have a small size, then it will move easily.
Small size, so NH3.
Small size, right? That is why NH3 will move easily. Now, if I am going to look at, this is known as sterics, है ना? Sterics is what the दो effect होते हैं mainly. आप लोग आगे अगर कभी chemistry पढ़ना हुआ, then you will see that there are two main effects that determine everything in chemistry, in organic chemistry basically, is the electronic effect and the steric effect. And the steric effect. If I'm going to look at the steric effect, then in that case, I will see that, see, if something is not going to move easily, how it can donate its electron pair? Makes sense. So nitrogen, the ammonia, the 1 degree, the 2 degree, the 3 degree, that means they have to move in order to donate the electrons, right? That is why, according to steric effect, NH3 should move easily and give the electron, followed by 1 degree, followed by 2 degree, and then followed by 3 degree. This is the order of basicity if I am going to look to the steric effect. Now you can easily see that these are conflicting results. Both of these are giving conflicting result. According to electronics, 3 degree should be maximum. According to sterics, NS3 should be maximum. So now what we can do, we have to rely on the actual experimental data. ठीक है? इस point को भी लिखिएगा, please write here. Since basicity is determined by multiple factors, with conflicting results, we will conclude according to the experimental values. ठीक है? So there are two cases that you have to memorize. One is when you have ethyl substituent. When you have C2H5, then in that case, 2 degree will be highest, followed by 3 degree, followed by 1 degree, and then ammonia will be the least. This is the experimental data. ये experiment से आया, ठीक है? That means if I'm going to look at the exact compound, so C2H5 whole twice NH, this is going to have the most basic character, followed by C2H5 whole thrice nitrogen, followed by C2H5 NH2, and then followed by NH3. Now, दूसरा जो आपको याद करना है, that is methyl substituent. when you have methyl substituent. Now, in this case, 2 degree, 1 degree, then 3 degree, and then NH3. So if I look at the exact compound, it will be CH3, whole twice NaH will be most, followed by CH3NH2, followed by CH3, whole thrice nitrogen. NH3. Raise your hand once you're done. इसके बाद आप लोग लिखिएगा aniline versus amine versus
Sir, can
ammonia.
you scroll up for a second, sir? More up,
How much?
sir. More up, more up, more up, sir.
Here.
Yes, sir. Done, sir.
Done. Raise your hand once you're done, guys. Aliza is done. Deborah, Rajita, and Fadil. Fadil, am I audible? Hello?
Yes, sir.
What happened? You are getting disconnected very frequently.
No, sir, not disconnected. Just start showing connecting. I didn't get disconnected, I think.
You were not disconnected.
No, sir, but it was just showing connecting on the screen.
अच्छा. Waiting for Aliza. We are done.
Yes, sir.
Okay. Waiting for Aliza and Fadil. Just waiting for Aliza now. Okay. No. We have seen already that amines are always what? Greater, they are more basic than ammonia. You have to look for aniline, basically. Yeah? So what is aniline? Aniline is a benzene ring that has NH2 group attached on it. Benzene ring. NH2 group attached on it. And this has a lone pair electron here. Now, because of this lone pair electron, it should be basic. But this lone pair electron is actually involved in resonance like this. Okay. Now, if it is involved in resonance, it is not available for the attack on, it is not available to act as a Lewis base. That is why anilines are less basic than amine. Right? Aryl amines, that is basically aniline also, are less basic than amine because less basic than amine because the lone pair the lone pair electron on nitrogen atom is delocalized due to resonance and makes it less available. ठीक है, and these are arylamines are also less basic than ammonia. Due to same reason. ठीक है, so in general what we have seen, amines are the greatest, followed by NH3. No matter what type of amine we are having, 1 degree, 2 degree or 3 degree, सारे के सारे amine is what are more basic than ammonia, and ammonia is more basic than aniline. Now, when we look at aniline, then in aniline, if you have any electron donating group, then it will increase the basic nature. ठीक है, तो अगर हम बेसिक नेचर पूछें, बेसिक नेचर, बेसिसिटी ऑफ aniline will be directly proportional to electron donating group. What are these? For example, CH3, OCH3. Okay, all of these are electron donating group, and it will be inversely proportional to electron withdrawing group. मेन एग्जांपल आप लोग लिख लीजिए, NO2, CHO and C double bond O. ठीक है, these are the main groups, electron donating and electron withdrawing. So if we have electron donating group present, then it is
Sir,
going to
is it the continuation of the basic character?
yeah, all of these are basic character only. Raise your hand once you're done. Waiting for Aliza and Rajita. Aliza, Rajita, and Fadil. Just waiting for Aliza now. See this question? They are saying arrange the following in decreasing order of their basic strength. Basic strength. So first of all, we will see this compound. What is this? This is basically aniline. C2H5NH2. This is what? This is 2 degree amine. No, 1 degree. C2H5. This is 1 degree amine, NH2. C2H5 volt-wise, this is 2 degree amine, and this is ammonia, NH3, right? Ammonia. Now, which one of them is going to be the most basic? So obviously, amines are going to be most basic, right? 1 degree and 2 degree. Obviously, in 1 degree, 2 degree में आपको देखना नहीं है, because 2 degree is always most basic. So if I take, say this is A, B, C, and D, तो 1 degree और 2 degree में सबसे ज्यादा basic कौन होगा? 2 degree, that is C option, followed by B. अब उसके बाद आएगा अमोनिया और एनिलीन में कौन ज्यादा होता है? Obviously, ammonia is more. We have just seen amines is amine के बाद ammonia, and then at last we'll have A, that is aniline. Make sense?
Yes, sir.
Yes or no? No. You can have some different type of question. थोड़ा सा इससे बस मतलब same concept वही है, but ध्यान दीजिएगा इसमें जरा. Next question that we have. इसका स्क्रीनशॉट ले लीजिएगा, ठीक है? Don't worry here. See. They are saying arrange the following in decreasing order of the pkb value. ठीक है? pkb value ये ध्यान रखिएगा. So directly pkb value मत देखिएगा. You try to arrange them in the basic order only. Now what is this? This is 2 degree amine C6H5NH3. Now you have to make the structure like this. It is going to be NH and this is CH3 here. ठीक है? Now C2H5NH. This is what? This is sorry. This is 1 degree amine. नहीं बार बार हम गलती करते थे. 1 degree amine. This is 2 degree amine. This is just aniline. ठीक है? Obviously, which will be the most basic if I am talking about the basic nature? Basic होगा सबसे ज्यादा 2 degree. Let me name it A, B, C, and D. So C is going to be the most basic. After that, we will have obviously the amine, that is A. Then if I compare B and D, then B में देखिए आप, B is attached with CH3 group. Now this CH3 group is going to give electron density. That is why we'll have B as the next basic, and the least basic will be D. Now, I think we should know is pKb is inversely proportional to the basic nature. अगर basic character high होता है तो pKb low होता है. That is why the pKb order will be, you will write everything as it is, C, A, B, D. Just flip the sign like this. That's right. अब आप लोग देखिए, एक चीज हम आपको बता देते हैं, इसके बारे में ना बहुत ज्यादा मत सोचिएगा कि डिक्रीजिंग ऑर्डर में लिखना पड़ेगा, वरना मार्क्स नहीं मिलेगा. आप लोगों को मतलब कुछ सेकंड क्लास थर्ड क्लास के बच्चे नहीं, जो असेंडिंग ऑर्डर और डिसेंडिंग ऑर्डर पूछा जाएगा आपसे ना. जो मेन चीज पूछना चाह रहा है, अगर कोई भी सवाल देने वाला है, वो ये पूछना चाह रहा है कि आप लोग पीके भी बताओ किसका ज्यादा होगा किसका कम होगा. सो आई सजेस्ट ईच एंड एवरी वन ऑफ यू, देखिए डिक्रीजिंग थोड़ा सा दिमाग लगाना पड़ जाता है ना, कि डिक्रीजिंग सबसे छोटा पहले लिखे, सबसे बड़ा पहले लिखे, ऐसे ऐसे. सबसे बढ़िया साइन लगा लो. द बेस्ट थिंग इज व्हाट, यूज द साइन. नो मैटर. अभी तो हमने देखिए, अगर आप ध्यान से देखिएगा, आई हैव रिटन इट इन इंक्रीजिंग ऑर्डर, बट कोई इसको गलत ही नहीं कर सकता है. ठीक है? बिकॉज आई हैव गिवन द साइन ऑल्सो. So please don't worry about the decreasing order कि decreasing order में ही लिखना पड़ेगा. No, just use the sign. और वहां पे लोग आपको ascending descending के लिए नहीं पूछ रहे. आपको हाँ, अब ये गलती कर देंगे अगर आप लोग, if you are writing like this C, A, B, D, अब ये आंसर गलत हो जाएगा बिकॉज देयर आर डिक्रीजिंग ऑर्डर और आपने साइन नहीं दिया, यू हैव जस्ट रिटन इट. ठीक है? चलिए, टेक अ स्क्रीनशॉट फॉर बोथ ऑफ दीज क्वेश्चन. राइट, नेक्स्ट साइलेशन. Acylation. So what is acylation? You have RNH2 and you react this with acid chloride. That means NeR dash C double bond O Cl. Now since this carbon atom, it is attached with oxygen and chlorine because both of them are both electronegative element. This carbon atom will have a delta positive charge. And the nitrogen atom will attack on this carbon atom because it has a lone pair electron. As soon as it attacks on the carbon atom, one of the pi bond will break and it will form R dash as it is, carbon with O negative. There will be nitrogen atom with the 2 hydrogens as it is and the R group as it is. ठीक है, देखिए नाइट्रोजन अटैक है ना, तो नाइट्रोजन का बॉन्ड बना कार्बन के साथ, everything is as it is. So since nitrogen is donating electron and it has got 4 bond, it will get a positive charge, and the chlorine is as it is here. Now you can see that this hydrogen atom, it will have delta positive charge because it is connected with nitrogen. It is already having a positive charge nitrogen atom, so it will pull the electron density, making the hydrogen very electrophilic. Now the chlorine atom, it has lone pair electrons, so chlorine atom easily attacks here on the hydrogen atom. Now as soon as the chlorine attacks, the nitrogen atom gives the electron density to the hydrogen atom gives the electron density to nitrogen and neutralizes it, and this bond breaks because chlorine can make only one bond. So as it tries to make a bond with hydrogen, this bond with carbon, it breaks down. As this carbon bond breaks down, this negative charge moves here and it makes C double bond. Now what happens and what you get is ये निकल जाता है, ठीक है, so you remove it, so you will have R dash C, this becomes double bond O, and then you have a bond with N. This nitrogen has only one hydrogen remaining bonded to R. So what is this? This is amide. This is amide, right? Now a similar reaction is shown not only by acid fluoride but other acylating reagent also. This is acid chloride. Similar reaction hota hai. I will write all the reagent, but please write aromatic and aliphatic amines. Aromatic and aliphatic amines. The important thing is only 1 degree and 2 degree are going to show this reaction because nitrogen के पास एक hydrogen जब तक नहीं होगा, this chlorine cannot attack, right? And 3 degree amines will not have hydrogen atom. That is why this reaction will not happen and it will go back to RNH2 and acid chloride. So it will write 1 degree and 2 degree amine reacts with acid chloride, acid anhydride, and esters to form amide. ठीक है, तो एक बेसिक छोटा सा एग्जांपल आपको दे देते हैं. You have 2 carbon atoms and NH2. एक काम कीजिए, you have 1 carbon atom CH3NH2, this reacts with you can have 3 carbon atoms COCl, or it reacts with double bond O. Here also C double bond O. This is acid anhydride. And last you have ester, C double bond O, OCH3. ठीक है, सो आपके पास ये पोर्शन जो है ना, C double bond O, this portion here, C double bond, this attaches on the nitrogen atom और एक हाइड्रोजन निकल जाता है. So आपको क्या मिलेगा? You will have this thing as it is, C double bond O, then it will be attached with nitrogen with 1 hydrogen and with CH3. Thus यहाँ पे आपके पास कोई भी alkyl group हो सकता है, any R. Similarly here also you will have C double bond O, NH, CH3. Here also you will have C double bond O, NH, and CH3. ठीक है, all of these are amides. अब इसका भी अगर आपको नाम देखना है, इसका भी नाम थोड़ा सा इंपॉर्टेंट है. So you can see all of these are same compounds, so I can write the name. Functional group is amide. The unsaturation is going to be AN. then the parent is going to be, see, this is amide, na? Ye C double bond ONH, right? So this 3 carbon atom, so it is prop. Now if I look at the substituent, so this CH3 substituent, CH3, that is methyl. Now where is the methyl attached? Methyl is attached on the nitrogen atom, so it is named as N-methyl. So name of all of these compounds are the same, that is N-methyl, N-methyl propanamide. Write this down. Raise your hand once you're done. Waiting for Aliza, Rajita, Fadil, yes, and Fadil. Just waiting for Fadil now. एक और रिएक्शन यहाँ पे है जो कि आपके टेक्स्ट बुक में दिया नहीं है, बट दे हैव आस्क्ड लाइक व्हाट डू यू थिंक विल हैपन व्हेन यू रिएक्ट एनी amine with carboxylic acid. So you have, let us suppose CH3COOH is an acid. You react this with amine, that is CH3NH2. Now this is obviously an acid, and we have just now seen that amines, they act as a base. So the reaction of these two are going to give you a salt. The salt that you're going to get is this hydrogen is going to be abstracted by the nitrogen's lone pair electron, and you will get CH3COO negative and NH3 positive, which is bonded with CH3. Okay. After this, you write the fifth chemical reaction that we have to see is the reaction with nitrous acid. Reaction with nitrous acid. Nitrous acid, I call it ONO. Okay. HNO2 is the formula, but according to structure, it is actually ONO. OH is bonded with nitrogen, which is doubly bonded with oxygen atom. Okay. ONO. You have seen this ONO many a times. Now, when
Sir,
it
can you
reacts
start
with,
up, sir?
yeah, sure.
Thank you, sir.
Reaction with nitrous acid. Okay. Now, nitrous acid banta kaise? So nitrous acid is actually made in with the reaction of NaNO2 and HCl. So for example, if I have primary amine, RNH2, and when you treat RNH2 with NaNO2 plus HCl, or if it has been written HNO2. ठीक है, एक ही चीज है दोनों. HNO2 is formed in the presence of NaNO2 and HCl at lower temperature. We get disonium salt, that is R N2 positive and Cl negative. ठीक है, this is quite unstable because of the N2 positive and Cl negative charges. Now it comes into contact with moisture, and in a bit of temperature also we get alcohol plus HCl. But if the same thing happens with aromatic amines, treat this with the same reagent NaNO2 and HCl or HNO2, same thing. We get benzene disonium salt, which is quite stable due to resonance. Okay, this is known as benzene diazonium chloride. Now, ये दोनों reaction important है, the primary amine or aromatic amine का. The 2 degree and 3 degrees are not very important, but you can still see if you have R2 alkyl group, 2 alkyl groups attached with nitrogen, it is further bonded with hydrogen, and if you react with ONO, HO, NO, then it is going to give you nitrosoamine. यहाँ से ऐसे पानी निकल जाएगा H2O, and you will have R2 nitrogen, that is doubly bonded with nitrogen, and this nitrogen is again doubly bonded with oxygen. So right, नहीं, एक second, this R2 में 2 बॉन्ड हो जाएंगे. हाँ ठीक है, this is nitrosoamine. ध्यान रखिएगा, when I am saying R2 bonded to N, it is actually R and R. There are 2 bonds ना, तो इस नाइट्रोजन का टोटल 3 बॉन्ड है. Nitrosamine plus you will get water. This is 1 degree amine. This is aromatic amine, and this is 2 degree amine. 3 degree amine में क्या होगा? You have 3 alkyl groups attached with nitrogen, and you react this with ONO. It's going to give you an unstable salt, that is R whole thrice, nitrogen with 1 hydrogen, the positive charge here, and NO2 negative. Then after warming it, you again get nitrosamine, that is R whole twice bonded with nitrogen, which is having a single bond with nitrogen, which is having a double bond with oxygen atom. Plus you will get ROH, alcohol. One of the alkyl groups is removed. These 2 reactions are not there in your textbook, by the way. After this, you will write the 6th reaction, that is reaction with aryl sulfonyl chloride.
Sir, how many reactions are there in this?
है आपके पास अभी बस एक reaction, और that means electrophilic aromatic substitution. And then in electrophilic aromatic substitution, we have bromination, nitration, and sulfonation. ठीक है. Then you have disonium salt also. Disonium salt में बहुत सारे reactions हैं. Reaction with, please write aryl sulfonyl chloride. Chloride. So aryl sulfonyl chloride is benzene ring, which is having a bond with sulfur, doubly bonded with oxygen, doubly bonded with oxygen, and then we have chlorine. ठीक है. This is also known as Hinsberg reagent. And this Hinsberg reagent, it is quite important because it is used for distinction of 1 degree, 2 degree, and 3 degree amines. So how do we distinguish it? See here. Now this Hinsberg region, it is going to show a very similar reaction as we saw in the case of acid chloride. ठीक है, तो वहां पे जैसे Cl HCl निकल जाता है ना, नाइट्रोजन से एक हाइड्रोजन, और एसिड क्लोराइड से क्लोरीन, उसी तरह का रिएक्शन होगा. वी हैव दिस बेंजीन सल्फोनिल क्लोराइड, and if you react this with nitrogen which has two hydrogens, an alkyl group, तो एक हाइड्रोजन और क्लोरीन तो निकल जाएगा. ठीक है. Now what will be remaining? See, benzene ring I am writing as pH, bonded to sulfur as it is, double bond O, double bond O. Further it will be bonded with, देखिए, सल्फर और नाइट्रोजन का बॉन्ड बनेगा जैसे कार्बोनिल कार्बन और नाइट्रोजन का बॉन्ड बनता है. सल्फर एंड नाइट्रोजन विल हैव अ बॉन्ड, एक हाइड्रोजन इज बीइंग रिमूव्ड. देखिए, बेसिकली दिस नाइट्रोजन एटम इज गोइंग टू अटैक ऑन सल्फर, और क्लोरीन और हाइड्रोजन निकल जाएगा. सो नाइट्रोजन इज अटैच्ड, और इसके साथ साथ होगा एक हाइड्रोजन एटम which will be having further bond with alkyl group, the R group. ठीक है. Now this particular hydrogen atom is important. This bond, this NH bond is important because this hydrogen atom, it is acidic in nature, because if you are going to remove this hydrogen, this nitrogen is going to get a negative charge which will be stabilized by the double bond O and then further the benzene ring. ये hydrogen जो है, it is quite important because it is what? It is acidic. This is acidic hydrogen. Therefore, this whole compound, it is soluble in alkali. Soluble in alkali. अगर हम बेस में इसको डालेंगे तो ये क्या हो जाएगा? डिसॉल्व हो जाएगा, बिकॉज एसिड बेस का रिएक्शन हो जाएगा. It will make a salt, so it will get dissolved. Then next, if you are having, let us suppose, nitrogen atom, and this has two alkyl groups and one hydrogen. ठीक है, two alkyl groups and one hydrogen. Then reaction will take place because hydrogen is going to attach with chlorine. So you will get pH bonded with sulfur, double bond O, and then the nitrogen atom, it will have alkyl groups only, no? R group here and one more R group here, because one of the hydrogen, एक hydrogen, and that hydrogen has been taken by chlorine. Now this does not have any hydrogen, acidic hydrogen. That is why it will not be soluble in alkali. No acidic hydrogen, therefore not soluble in alkali. ठीक है, it is not. पहला वाला 1 degree soluble, 2 degree is not soluble, and the 3 degree will not even show the reaction because it does not have any hydrogen in the nitrogen atom. So it will give you no product due to absence of hydrogen atom on nitrogen. ठीक है, please copy this down. Raise your hand once you're done. Please raise your hand once you're done. Just waiting for Priya now.
Done, sir.
Yeah. ठीक है. After this, write 7th electrophilic aromatic substitution of aniline. Aromatic substitution of aniline. ठीक है. Now, few points. First of all, NH2 group is highly activating due to highly activating and लिख लीजिए and ortho-para-directing due to plus M effect. Due to plus M effect. Nitrogen atom, it is having lone pair, so ये क्या करेगा, इलेक्ट्रॉन डेंसिटी देगा. ठीक है. So what we are expecting? We are expecting that it is going to react very fastly. The rate of reaction will be very fast when compared to benzene because it is highly activating and is also ortho-para-directing because of the plus M group. So we'll see the first reaction, that is bromination. Now in bromination, it is so highly activating group. It increases the reactivity so hugely that we don't need any catalyst. Just bromine water is enough for this reaction. And we don't even get one product we don't even get a mono substituted product. Rather, we get a tri substituted product. The reactivity is so high that all the ortho and para positions have been substituted with bromine. ठीक है. Why it is happening? Due to high activating capacity or high activating क्या नाम है इसका, NH2 ग्रुप. सबसे पहली बात तो ये. ठीक है. Because it is highly activating. They will ask you why does it give tri substituted product, then you will see that you're going to say that because the NH2 group, it is highly activating in nature. Now this is also a problem, right? What if we need a mono substituted product? I need bromine in only one position, then what do I do? So to do that, we have to control the activating nature. Activating nature आ कहाँ से रहा है? Because of this lone pair. This lone pair is moving down the benzene ring. तो इसको हमको रोकना है. ठीक है. I want to divert this lone pair somewhere else. So what do we do? Please write to control.
Sir, but by putting Br2 itself will get in 3 position.
Sorry.
No, but by putting Br2 itself will be getting in 3 position. Bromine.
Yes. Your question is where is the third bromine coming from?
Yes, sir.
Think about it, Sia. Think about it. Think about it. Like try to picture yourself in a lab. When you're adding bromine, so सिर्फ you will have two bromine atoms only. There will be millions of bromine atoms.
Yes, sir.
Tell me, please. Got it?
Yeah.
ठीक है. So see, stoichiometry, भले ही I know, I understand. When you start doing chemistry in the 9th standard, सबसे पहली बात एकदम भर भर के दिमाग में ठूस दिया जाता है आपके stoichiometry, right? Stoichiometry, balancing. but later on you will realize that, so for example, balancing is not a very huge part in organic chemistry. ठीक है, इसका ध्यान रखिएगा. Fine. We are mainly interested in the product that we are going to get. So whenever you are adding something, so please imagine that you are having millions of molecules. You're not having one aniline or one bromine. You're having millions of molecules. Okay. ठीक है. चलिए, right here next, to control the highly activating nature, the highly activating nature and get activating nature and get mono-substituted product acetylation of aniline is done. ठीक है. आपसे सवाल आएगा, गिव रीजन acetylation of aniline. Give reason acetylation of aniline. You will write this. To control the highly activating nature and get mono-substituted product. That's it. ठीक है. होता क्या, अब कैसे होता है उसके लिए अलग से देखेंगे, बट होता क्या है यहाँ पे, एसिटाइलेशन. You have NH2 group. You're going to treat this with acid anhydride and acetic anhydride. That means CH3 C double bond O, oxygen, and then CH3 C double bond O. This can also be written as CH3 CO whole twice and oxygen atom. ठीक है, ऐसे भी लिखा जा सकता है. Now it is going to show you what the acylation reaction. Benzene ring as it is, nitrogen में एक हाइड्रोजन बचेगा, and this nitrogen will be attached with C double bond O CH3. Now this lone pair electron, which was in resonance with the benzene ring, it will now be in resonance with the carbonyl group also. ये इधर भी रेजोनेंस कर सकता है, राइट, और ये इधर भी रेजोनेंस कर सकता है. ठीक है. सो what we thought of doing was diverting the lone pair. The lone pair was only going to the benzene ring and increasing the electron density. We did not want that, है ना, हम लोग को वो चाहिए नहीं था. What did we want? We wanted that the lone pair electron of the lone pair electron of the nitrogen atom should be diverted, and we have done that. And then you add Br2. Obviously, you can see that the ortho position, it is very hindered, and here we are having CH3. Okay. Now, since this can be rotated, this ortho is also very hindered. You will get a maximum or the major product as the para product. This benzene ring will be as it is. You'll have nitrogen, hydrogen, C double bond O, CH3, and the bromine will attached on only para position. ठीक है. दो तरीके से हम लोगों ने कंट्रोल किया. First is, as soon as you added the group, the ortho positions are hindered and no attack can be occurring from the ortho position. So we have only one position available, that is the para position. Also, one more thing that we have done is what we have decreased the electron density of nitrogen lone pair because it is diverted towards the carbonyl group. ठीक है. So this is known as protection. We have protected the ortho group. ठीक है. प्रोटेक्शन डीप्रोटेक्शन बाद में पढ़ेंगे आप लोग. बाद में मतलब अब तो 12वीं आ गई, मतलब आगे अगर आपने केमिस्ट्री लिया तो वंस यू हाइड्रेटेड, इफ यू ऐड H2O इन द प्रेजेंस ऑफ H प्लस और बेस, एसिडिक और बेसिक हाइड्रोलिसिस, इट इज गोइंग टू रिटर्न बैक द एनिलीन. द Br विल बी एज इट इज, और यहाँ पे आपके पास NH2 आ जाएगा. ठीक है. सो दिस इज हाउ यू आर गोइंग टू डू ब्रोमिनेशन इफ यू वांट ओनली मोनो सब्स्टिट्यूटेड प्रोडक्ट. नाउ when when we are doing the acetylation, what is happening actually, and why it is decreasing the reactivity. तो इसको लिखिएगा, after acetylation the lone pair of nitrogen atom interacts with CO due to resonance, and hence makes the lone pair electron less available for benzene. This decreases the activating nature. This decreases the activating nature, leading to formation of mono substituted product. दो सवाल है. एक सवाल, why is acetylation done? ठीक है. Give reason. Acetylation of aniline. Another question that will be asked is, give reason. After acetylation, aniline gives monosubstituted product. Both of these are confusing question. ठीक है, ध्यान रखिएगा इन सब चीजों का. Give reason, acetylation of aniline. That is one question. Why is acetylation done? To control the highly activating nature of what? Highly activating nature of NH2 group and get monosubstituted product. That is why acetylation is done. Another question. After acetylation, aniline gives monosubstituted product. You have to explain this. Why? Acetylation में ऐसा क्या हो जाता है? Then you will say that after acetylation, the lone pair of nitrogen atom interacts with CO due to resonance and makes sense. Aliza, Fadil, Deborah, Fia, yes or no? Please tell me.
Yes, sir.
ठीक है, इसका ध्यान रखिएगा. There are two very similar questions. इसमें साथ साथ आप ये भी लिख लीजिएगा. How it is showing resonance. ध्यान दीजिए. So if you have the benzene ring, then you have nitrogen atom which is having C double bond O and then CS3, right? This is what we are getting after acetylation. This nitrogen atom is going here, this carbon atom's oxygen is going there, and you have pH, then you have nitrogen that is doubly bonded with carbon, then this carbon is singly bonded with O negative, then you have CS3. ठीक है, this is how the resonance is taking place. आप इसको diagrammatically भी show कर सकते हैं. Why? What is happening? Now this nitrogen lone pair less available for benzene after acetylation. Copy this down. Raise your hand once you're done.